Today we are covering FRQ topic number 8. This is polars. Some of these are with a calculator, some without. You can see the recent years that they tested it. For a while they tested it very regularly, but it's been quite some time since we've had a full FRQ just with polars. Alright, who knows? May I say this every year? I've been saying this for 5 years now. Maybe we are due, or maybe they have decided to just put these on multiple choice questions. I still keep it as a topic because I still feel like, since they liked it for so long, I feel like it could come back. Alright, part A almost always asks you to find the area of some shaded region. Usually, if that's the case, they will give you a graph. That doesn't mean you can't, if you have a calculator, you can still put in your calculator, but usually they give you a graph for that. Sometimes you're only given one polar curve, sometimes two. These are very logical, so think about what your boundaries need to be. Okay? Your polar area formula is crucial that you know this. It is the integral from a to b of 1/2 r squared. Remember, with polars, your equation is not y equals, it's r equals. Instead of x's, they're all thetas. So r squared, which will have thetas in it, d theta. These are theta boundaries. So that's the hardest part of it, is determining your theta boundaries. Your lower boundary must be smaller than your upper boundary. Like always, but I just want to reiterate that. The boundaries for integrals, therefore, must go counterclockwise because that's how you increase your thetas. Use symmetry to make your life easier. Try to start at 0, pi over 2, pi, 3 pi over 2, or 2 pi. Either start or end there and use symmetry. Okay, and the other key formulas. X equals r cosine theta gives you the x coordinate of the graph. Y equals r sine theta gives you the y coordinate. Use these two anytime you're asked anything about x and y when you're in a polar question. For the slope, it's dy dx. So that is y prime over x prime, dy d theta over dx d theta. So take your time on those, especially if you don't have a calculator. Take your time, make sure you get those right. The sine of dx d theta determines if your point is moving to the right or the left. So dx d theta still indicates horizontal movement as theta increases. Dy d theta determines vertical movement. Upward if it's positive, downward if it's negative, just like for parametrics and vectors. The sine of dr d theta determines outward or inward, away from the origin or towards the origin movement as theta increases. Most of the time in these, when they ask you a question like that, r will be positive, so you just do it that way. In most polar questions, I've noticed they always have r to be positive in them. Not always, but in most. So the distance from the origin to the point is just r. But if you have some kind of inner loop or some kind of indication that there will be some negative r values, then you need the absolute value of r to be the distance. So if you're finding the maximum or minimum distance, remember that it's the absolute value of r, not just r. Okay, the distance between two polar curves. I think of it as outer minus inner. Outer minus inner for distance between two curves. The rate that is changing then would be the derivative. Okay. The average value would be the average value if you have a calculator. Okay. Let's see. Oftentimes in a part D, you'll be told that there's a particle moving on the curve, on one of the polar curves involved. So those are not bad. You just take the derivative of both sides with respect to t if you want to find the rate that r is changing. Okay. We are going to do, let's see if I can get this. Okay. We're going to do the FRQ from 2018. Okay, this one was without a calculator, so no calculator on this one. Okay, the graphs of polar curves r equals 4 and r equals 3 plus 2 cosine theta are shown on the right. R equals 4 is the circle. R equals 3 plus 2 cosine theta is the limacon, no loop. The curves intersect, they tell us, at pi over 3 and at 5 pi over 3. That was nice of them to tell us that. Usually we do that on our own. But that is theta equals pi over 3 and 5 pi over 3. If you recall, this is what we did on these types of problems. We always did the little theta lines where they intersect. All right, part A. Let R be the shaded region that is inside the graph of r equals 4 and outside the graph of the limacon. So they always do that. They will show you the shaded region and they will describe the shaded region. Okay? Write an expression involving an integral to find the area of R. So write an expression involving the integral. We don't actually have to find the area. We just have to write an expression that would give the area. So for part A, integral area, when I see area, I think integral 1/2 r squared d theta. Okay? So the integrand will be 1/2 r squared d theta. So for this one, think about this. Outer minus inner. If it was, if we were in just regular functions, it would be top minus bottom, right? Well, this, with polars, it's outer minus inner. Outer is 4, inner is the limacon. So we want to find, essentially we're finding this area, the whole thing, all of that area, and then we're subtracting out the limacon area. So 1/2 4 squared will give us this entire Pac-Man shaped thing, region, and then we're going to subtract out the area of the limacon. So that gives it to us. That gives us the area of the shaded region. You guys, that was worth 3 points this year. 1 point was for the constant, which would be the 1/2, and the limits of integration. 1 point, or 2 points was for the integrand. I'm sure they split that up somehow, but I don't know how they split that up. Okay, part B. Find the slope of the tangent line to the graph of the limacon at pi over 2. Slope of the tangent line is dy dx. Okay, so I'm using y is r sine theta and x is r cosine theta. And we're going to do dy d theta over dx d theta. So what is dy d theta? R is, they tell us what R is. R is 3 plus 2 cosine theta. In fact, I might write that down. 3 plus 2 cosine theta times this sine theta. So I'm going to find dy d theta of that. So product rule, the derivative of the first thing is -2 sine theta times the sine theta left alone, plus for product rule. Now I'm leaving the 3 plus 2 cosine theta alone, and multiplying by the derivative of sine theta divided by, now we're doing over x dx d theta, so x here is 3 plus 2 cosine theta times cosine theta, right? So product rule on that, we start with the derivative of the first thing, so that's negative 2 sine theta still, times cosine theta, plus, now we're leaving the 3 plus 2 cosine theta alone, and multiplying by the derivative of cosine theta, which is negative sine theta. So that is dy dx, and now we're trying to find, now they tell us to put in pi over 2 for theta. So we have a choice. We can actually find out what these trig values are at pi over 2 if you feel very, very confident in yourself at this point in the game. Go ahead and do that. Otherwise, a safe stop spot would just be to literally rewrite this, replacing every theta with pi over 2. I feel very certain that I could figure out these values of sine of pi over 2 and cosine of pi over 2. But if I was in a test like you guys are going to be, and this is number 5 in the FRQs, you're about 3 hours into this exam, I would rather you safe stop on something than to make a silly mistake and not earn a point that you truly should have earned. So just safe stop on that. That's my best advice. That was part A up here. For part B, this was how this was scored. 1 point for either the correct dy d theta or the correct dx d theta. 1 point for either one of those. 1 point if both of them are correct. So dy dx in terms of theta. And then 1 point for your answer. Now, would you have gotten full credit if you had just written down your answer? Yes. If it was correct, you would have gotten full credit for just the answer. In other words, I didn't have to write this with the thetas in it. However, if you did, if you went straight to your answer, you have to say that it is dy dx at pi over 2. We cannot say that this is equal to that without saying it's at theta equals pi over 2. Okay? Because this expression has thetas in it. This expression does not. Okay? All right, part C. All right. A particle moves along the portion of the curve of the limacon between 0 and pi over 2. So here's the limacon between 0 and pi over 2. So we can consider, we're only considering this section right here. I just realized something. As I was just doing that, for part A, I did not get full credit for that, did I? I never did include those limits. What would the limits of integration be here? Start at pi over 3 and go to 5 pi over 3. Now I've got full credit. Okay? Goodness. Glad I saw that before I turned in my test, yes? Okay, part C. So here we are on that, in the first quadrant on that curve. The particle moves in such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. The distance between the particle and the origin. The distance between the particle and the origin is r. That's the distance between the particle and the origin, right? So they're telling me that R increases at a rate of 3 units per second. That tells me that dr dt, I'm going to write that down, dr dt is 3 units per second. Find the rate at which the angle theta changes with respect to time. So find d theta dt at the instant when the position of the particle corresponds to theta equals pi over 3. Indicate units of measure. I hope I don't forget that. Okay, do something on here to tell yourself to do units. Maybe you won't forget it if you say that, right? Okay, so I don't find these very hard because they told me what R is equal to, and we want to find d theta dt. If I want to find d theta dt, and they give me an equation with theta, I take the derivative of both sides with respect to t. So we're taking the derivative of both sides with respect to t. We get dr dt is equal to -2 sine theta d theta dt. A little implicit differentiation there. And now they plug in pi over 3 for theta and 3 for dr dt. And now I'm going to divide both sides by the -2 sine of pi over 3. And again, this is a safe stop spot, okay? As long as I give the units, I'm all done, I think. So units for this, what would be the units of, here's my fraction, right? I need units of theta divided by units of t. They told me units of t were in seconds. So units of theta must be radians. Units of time, they tell me, are seconds. Radians per second. This was scored at another 3 points. So 1 point was for, this is how they wrote this. dr dt is equal to dr d theta times d theta dt. We did that when we did the implicit differentiation here. This was dr d theta. This is d theta dt. 1.4 d theta dt is equal to 1 over -2 sine of theta dr dt. So in other words, get d theta dt by itself, and then 1.4, the answer with units. Okay. So some of the things that they could ask you in a polar FRQ.